What's going on, everybody? Got another video here for you. We are going to look at separable equations. We're going to do some differential equations, solving them. All right, so definition, separable equations. A first-order differential equation of the form dy dx is equal to g of x times h of y is said to be separable or to have separable variables. So here's two examples here. This equation is separable, and this one is not. So basically, what you're wanting to do is you want to be able to get all the y terms with dy and all the x terms with dx. So let's just take a look at this one right here. Okay, let's take a look at that one. And I'm going to show you how it's separable. So we've got dy dx is equal to y squared x e to the 3x times e to the 4y. You see that? See this right here, I just wrote that as multiplication because if you have like bases, you add the exponents. All right. So now I've got dy is equal to y squared x e to the 3x e to the 4y dx. I just multiplied the dx to both sides. And now what I'm going to do is I'm going to divide everything by y squared e to the 4. This is a 4y here that kind of looks like an x, but that's a y. I'm going to divide everything by y squared e to the 4y. So when I do that, I get e to the negative 4y over y squared dy is equal to x e to the 3x dx. And you can see all the x terms I got with dx and all the y terms I got with dy. And that's basically what we're wanting to do to be able to solve these things. Okay? All right. So let's look and see how we solve these things. So we have one here that we want to solve. So let's move this y dx to the other side. So we have 1 plus x dy is equal to y dx. And so that's going to give me 1 over y dy equals 1 over 1 plus x dx. All right, so now what we do is we want to integrate both sides. So I'm going to integrate both sides. And that's going to give me the natural log of y is equal to the natural log of 1 plus x plus, now let's write this as plus c1. Okay, now whenever you're doing that, there's no need to put a constant over here on the left hand side. In other words, I mean, if you wrote, say, natural log y, say, plus c2 equals natural log 1 plus x plus c1. Okay, if you move the c2 over, you're going to get c2 minus c1 for your constant over here. And this is just some arbitrary constant, and we could actually just write that as c. Okay, so there's no need to put the plus to add the constant on the left hand side. You just want to add it over there to the right hand side. All right, so now let's go about maybe rewriting this thing. So this would be the absolute value of y, okay, is equal to e to the natural log 1 plus x plus c1. So all I did is I just raised both sides to the e power. Okay, so I got e raised to all of this, and then e raised to the natural log of y is just your absolute value of y. All right. And so now we've got the absolute value of y is equal to e to the natural log 1 plus x times e to the c1. All right. And so now we got absolute value of y is equal to absolute value 1 plus x times e to the c1. E to the natural log of absolute value 1 plus x is absolute value 1 plus x. And now, if we want to, we can get rid of these absolute value. We can write y is equal to plus or minus e to the c1 times 1 plus x. All right, so where does that come from? Well, to get from this step to this step, you've got absolute value of 1 plus x is equal to 1 plus x if x is greater than or equal to -1. Because if x is greater than or equal to -1, this inside here would be positive. And then the absolute value of 1 plus x is equal to -1 plus x. That's if x is less than -1. So if x is less than -1, like -2, -3, this inside here would be negative. So we got to do the negative of that to make it positive. Okay, so that's how we go about getting that. All right, now let's come up here and let's replace, let's let c, okay, let's let c equal plus or minus e to the c1. We're going to replace plus or minus e to the c1 with a c. It's just an arbitrary constant. We can do that, okay? And so that would give us y is equal to c times 1 plus x. And that right there would be our solution, okay? Now, let me show you something else here that we could do, okay? Let's write constant of integration, you know, our c, as the natural log of c. So let's erase this here. Let's erase this e here and this e here. This would be natural log. So take a look at this step here. All right. So instead of writing our constant of integration as c1, let's write it natural log absolute value of y is equal to the natural log of 1 plus x plus natural log of c. Let's write it like that. We're going to write our constant of integration like this, okay, instead of c1. This may make it a little easier for us to simplify it. So if you look at this, we've got natural log y is equal to the natural log of c times 1 plus x. All right, addition that comes together is multiplication, and so that means y is equal to c times 1 plus x. See there? In order for those two sides to be equal, this has to equal y. All right. All right, so let's continue on. All right, so let's solve this. This is an initial value problem. See how we have a condition here? All right, so let's separate the variables. So I'm going to bring the y up here, the dx up here, basically just kind of cross multiplying. So I've got y dy equals negative x, equals negative x dx. And then we want to integrate both sides. Y dy equals integral negative x dx. And so this is going to give us 1/2 y squared equals negative 1/2 x squared plus, and we'll say plus c1. And so if I move the minus 1/2 x squared to this side, that's going to give me 1/2 x squared plus 1/2 y squared equals c1. And then I'm going to multiply everything by 2. That's going to give me x squared plus y squared equals 2c1. Okay. All right. So now let's replace 2c1 with c squared. So that's going to give me x squared plus y squared equals c squared. Okay. It doesn't matter. We can replace it. It's just an arbitrary constant. Okay. This just looks better. This looks more like the equation of a circle when you see the x squared plus y squared equals c squared. So we're solving for c squared instead of 2c1. See, look, I've got to plug the 4 and the negative 3 in, all right? So let's just do that. So I've got 4 squared plus negative 3 squared equals c squared. So this tells me that c squared is equal to 25. And so now I've got x squared plus y squared equals 25. Okay. All right. Now, look, if I would have let's just say I wouldn't have replaced it, and I would have put the 4 in for x and the negative 3 in for y equals 2c1, I would get 2c1 is equal to 25, and this would be replaced with 25. You see that? All right. So basically what we have here is circle with radius 5. Okay. So what we want to do now is we want to, and this is an implicit solution. This is an implicit solution. And what we want to do is solve for an explicit solution that satisfies the initial condition. Okay? So if we solve this thing for y, that's going to be y equals the square root of 25 minus x squared. And remember, that is plus or minus. Okay? It's plus or minus. But remember, we want it to satisfy the initial condition, which is this thing. I'm going to write that down here. I'm going to write it down in green. We've got y of 4 is equal to negative 3. So if I plug the 4 in for x, well, how am I going to get the negative 3? If I have y equals whoops, let me change colors. If I have y equals negative square root of 25 minus x squared, and this is for x between negative 5 and 5. Okay, and you can see if we graph that, that would look like that. I know that circle doesn't look good, but it's supposed to be a half circle underneath, and the center is at the origin. All right. So, I mean, you see, they're really not that bad. They're not bad at all. All right. Here we have losing a solution. Some care should be exercised in separating variables, since the variable divisors could be 0 at a point. If r is a 0 of the function h of y, then substituting y equals r into dy dx equals g of x times h of y makes both sides 0. In other words, y equal r is a constant solution of the differential equation. But after variables are separated, the left-hand side of dy over hy is equal to g of x. dx is undefined at r. Okay, see if h of y would be 0. As a consequence, y equals r might not show up in the family of solutions that are obtained after integration and simplification. Such a solution is called a singular solution. All right, so does that make all kinds of sense there? Well, let's look at it. And we're going to explain all what we just read. We're going to explain all that in this example here. All right, so let's solve this. Okay. All right, so if we get it in the form, we're going to have dy over, well, let's see, how do I want to write that? Let's write it as 1 over y squared minus 4 dy equals dx. Okay, so I moved the dx up here, and then I divided both sides by y squared minus 4. All right. Well, now we've got to integrate both sides. Now, if you look at this, how am I going to integrate that right there? Well, I'm going to do this real quick. I'm going to erase it after I do it, but you should already know how to do this. So we've got 1 over y minus 2 times y plus 2. All right, that is going to be that's going to be a over y minus 2 plus b over y plus 2, and you probably have a good idea what we're fixing to do. That would be correct. We are partial fraction decomposition. So when we multiply both sides by y minus 2 times y plus 2, I'm going to go through this part kind of quick. We're going to get 1 is equal to a times y plus 2 plus b times y minus 2. And then if we let y equal 2, that's going to go to 0. That's going to be 4a. We get 1 equals 4a. A is equal to 1/4. And then we'll let y equal negative 2. So that's going to go to 0. That's going to give me 1 equals negative 4b. And so b is equal to negative 1/4. Okay. So basically, I can rewrite this as 1/4. And then the negative 1/4 would make that minus 1/4. And there's your partial fractions. Okay. All right, so that's just a quick review on that. I know you've done it before, but might have forgot how to do it. All right, so let's integrate both sides. So I'm going to integrate both sides. I've got 1/4 over y minus 2 minus 1/4 over y plus 2 dy equals the integral dx. Okay. All right, so integrate both sides. I'm going to get 1/4 natural log y minus 2 minus 1/4 natural log y plus 2 equals x plus, and let's call that C1. All right. So now let's multiply everything through by 4. So I'm going to get natural log y minus 2 minus natural log y plus 2 is equal to 4x plus 4c1. All right. And so let's write this as natural log y minus 2 over y plus 2 subtraction comes together as division, equals 4x plus. Now, instead of writing the 4c1, let's just write that as plus c2. Let's replace 4c1 with c2. Okay? And so let's raise each side, or let's do e raised to each side. So if I raise this, if I put an e here and an e here, that's going to give me y minus 2 over y plus 2 is equal to e to the 4x plus c2. Okay, and we got our absolute value here. And so splitting this up, that's going to be y minus 2 over y plus 2 is equal to e to the c2 times e to the 4x. And so that's going to give me y minus 2 over y plus 2 is equal to plus or minus e to the c2 e to the 4x. All right. Oh, I'm about to run out of room here, aren't I? All right. So what I'm going to do now is I'm going to just rewrite this up top. Okay. Well, no, I'll tell you what. Yeah, let's rewrite it up top. And what I'm going to do here is this constant here, I'm going to replace it with a c. Okay. So rewriting that up here, I've got y minus 2 over y plus 2 is equal to ce to the 4x. Okay. All right, now let's solve this thing for y. So I get y minus 2 equals ce to the 4x y plus 2c e to the 4x. I multiplied this up here and I just distributed it to each term. And so now I've got y minus ce to the 4x y is equal to 2c e to the 4x plus plus 2. So everything with a y came to one side, everything that didn't have a y went to the other side. And so this is going to give me y times 1 minus ce to the 4x equals 2 times 1 plus ce to the 4x, factored out of 2. And so I get y is equal to 2 times 1 plus ce to the 4x over 1 minus ce to the 4x. All right. So there you have y. All right. Now, let's go up to what we learned up here. Okay. Notice how when I divided both sides of this, I got this right here. And notice how this thing is undefined at plus or minus 2. Okay, it's undefined at plus or minus 2. And basically what we have here is where is it? How the dy dx equals this, where that's 0. Well, I have dy dx is equal to y minus 2 times y plus 2. Okay, see, all I did is I took this right here and I factored this part. Okay, all right. Now we have y equals 2 and y equals negative 2. These are equilibrium solutions. Okay. All right. Y equal 2 is a member of the family of solutions. corresponding to c equals 0. So in other words, if we replace the c with a 0, okay, this term would go out, this term would go out. We would have 2 times 1 over 1 is 2. Okay, so that would be 2 over here, and the y equals 2, we would have 2 equal 2. Okay, now we have y equals negative 2 is a singular solution. Okay, this cannot be obtained for any choice of c. Whatever we want to make c, it's not going to be satisfied. Okay, so the question is, what is a well, let's just say that. So basically, we must we must prevent y equal plus or minus 2. Okay, so our solution here, that's going to be everywhere except for plus or minus 2. Now, what is a singular solution? Well, let me just kind of write that out. I'm going to erase this. I didn't leave myself enough room here, but we'll all right, so we'll write it in this singular solution. All right, this is a solution that is not a member, like the negative 2 is not a member of a family of solutions of the equation. See, you know, we can't use the plus or minus 2, but notice the positive 2 was a member of the family, but the negative 2 was not, because there was no c value we could use to get that equation true. So that is a solution that cannot be obtained by specializing any of the parameters, that's your c value, in the family of solutions. See, I tell you, you know, the one thing about these differential equations, you're seeing all these terms, parameters, singular solution, all that kind of stuff. That's just the definition and terminology. It's important to know the definitions and the terminology, what these words mean. And if you need a refresher on that, I've got a video, differential equations, definitions, and terminology. Watch that video. We go over all that stuff. All right, so now let's take a look at this one. We just got several examples to work here. All right, so let's go ahead and see if we can get all the y's with dy and the x's with dx. So this is going to be e to the 2y. Let me change back to this one. We've got e to the 2y minus y times cosine x dy equals e to the y sine 2x dx. Just multiplied everything through by dx. And so now we're going to have e to the 2y minus y over e to the y dy equals sine 2x over cosine x dx. All right. All right, so now we've got to integrate this, and that's probably going to be what you have trouble with the most, is actually integrating this stuff. Okay, so let's see what we're going to do here. We've got this e to the 2y minus y over e to the y dy equals, now look at this, we've got sine 2x and cosine x. Well, we can write the numerator as 2 sine x cosine x, right? Your double angle identity. And so that is going to give us what? That's going to give us the integral e to the y minus y e to the negative y dy equals, let's write this as 2 sine x dx. Okay, so all I did is I split that up, e to the 2y over e to the y minus y over e to the y. So subtract exponents, that's e to the y, and then I just moved that up. Okay, that's all I did there, and that's where I got that from. All right, so now let's go ahead and just kind of, I have a lot of room. Oh yeah, I left myself a bunch of room here. All right, so let's write this over here, e to the y dy minus y e to the negative y dy equals, and then this over here, that's going to be what? Negative 2 cosine x plus c. All right. Oh, and notice one thing over here. We do have a we do have a condition here that y of 0 is equal to 0, so we'll be able to figure out what c is. All right. So obviously here we've got e to the y minus. Now we've got to integrate this thing. So what I'm going to do is I'm going to go off to the side, which I'm going to work it right here, and then I'll erase it. But you can go off to the side and do this. So we've got integral y e to the negative y dy. All right. So we've got what? We've let u equal y, dv equals e to the negative y dv. And so we got du is equal to dy. V is negative e to the negative y. That's right, we're doing integration by parts. All right, so that's going to be negative y e to the negative y minus, and then this times this. So this negative and this negative is going to make a positive, integral e to the negative y dy. So that's negative y e to the negative y minus e to the negative y. And then, you would have plus c, but we're not going to put the plus c on that side. Okay. And so this is going to be minus negative y e to the negative y minus e to the negative y. Oops, let me erase that. And that is equal to negative 2 cosine x plus c. All right. And so we just did integration by parts. And so clearing this parenthesis, that is going to give me, let's see, what is that going to be? E to the y plus y e to the negative y plus e to the negative y equals negative 2 cosine x plus c. All right, and so remember, we have our condition, y of 0 is equal to 0. So e to the 0 plus 0 e to the negative 0 plus e to the negative 0 equals negative 2 cosine 0 plus c. So this is going to go to 0. That's 1. That's 1. So I get 2 equals negative 2. Cosine 0 is 1 plus c. So this tells me c is equal to 4. And so what I'm going to do is come back and plug that c into there. So I get e to the y plus y e to the negative y plus e to the negative y is equal to, put the 4 in for c, 4 minus 2 cosine x. And there you have it. All right. So see, it's not too bad. Like I said, the thing that's going to get the thing that's going to get the messiest, I guess you could say, is doing the actual integrals. You can see one of them we had to do partial fraction decomposition. Another one we had to do integration by parts. I mean, you could have some where you may have to use trig sub. You never know. Okay, it could happen. So that's you've got to make sure you know how to do your integrals. All right, what about an integral defined function? If g is continuous on some interval I containing x0 and x, then a solution of the simple initial value problem dy dx equal g of x and y of x0 is equal to y0 defined on I is given by y of x is equal to y0 plus the integral x0 to x g of t dt. And what we're doing is we're changing our variable from x to t. That's all we're doing. Okay. All right. So let's look at this example. So it says solve dy dx equals e to the negative x squared. Now notice here, this is our y of x0 equals y0. That's that part. All right. So if we want to solve this, okay, we're going to have dy is equal to e to the negative x squared dx. Okay. All right. Now we need to integrate this thing. But think about this. Think about it like this. How in the world are we going to integrate this thing, this e to the negative x squared? You can't do it, okay? You can't integrate it. So we're going to use this, okay? So I've got the integral of the integral dy, and we're going to go from x0 to x, right? We're going from x0 to x. That is equal to the integral 3 to x e to the negative x squared dx. Oh, I'm sorry. How stupid was that? Negative t squared dt. You get used to writing x all the time. Okay, so remember we're changing we're changing it into to t, and I guess let me rewrite this dy. We're doing dy dt dt. Okay, we're changing the variable to t. So instead of writing dy, I'm going to do dy dt dt. Okay, and so now that's going to give me y of t, right? Integrating with respect to t, integrate dy dt, that's going to give me y of t, and that's going to go from 3 to x is equal to 3 to x e to the negative t squared dt. All right. And so now if we evaluate this side over here, that's going to be y of x minus y of 3 is equal to 3 to x e to the negative t squared dt. All right. So one thing I want to point out, you've got this right here. Don't try to memorize it's y of x, y0. Okay, don't try to memorize that. Just come down here and do this integral here and plug that in, and then all it is y of x is equal to y of 3 plus 3 to x e to the negative t squared dt. See, once I do this and then I move that to the other side, I'm right here. Okay, I've got this. And so, well, this is going to be y of x is equal to y of 3. Well, what's y of 3? Y of 3 is 5. And so that's going to be 5 plus 3 to x e to the negative t squared dt. And there's your answer. All right. So there you have it. That's one method of solving differential equations. That's the thing about this class. What you want to do is you want to look at your equation. What do I have? Okay, well, this is the kind of equation I have. This is the method I'm going to use to solve it. Okay, these are separable equations. And as we go through the course, as we go through these videos, and you go through your differential equations class, that's what you're going to do. So we got separable equations. Then you're going to have another kind of equation, another kind of equation. Well, this is how I solve it. All right. So I hope this video helped. Check out my other videos. Give me a like, share, subscribe, comment. And I will see y'all in the next one. Later.